In this video, we will talk about recursive CTE. What is it, how it works, and in which cases it is supposed to be used. But first, let's recall what is CTE, which means Common Table Expression. For this lesson, I will use AdventureWorks 2017 database, which is a free sample database from Microsoft and can be easily found in Internet. Let's take a simple statement, which returns a valid result set. This query returns us a total count of customers for each territory, from sales customer table. Let's run it. We may refer to this query as a table expression. CTE is a named table expression, which is visible only to a statement that defines it. So in our case, we can name this result set as, for example, ter count, and then in the same statement refer to it by that given name. Like that. You see that here? We are referring to previously defined expression by its given name. And now, we can query our CTE, and perform operations on it. CTE definition begins with clause. You can define multiple CTEs. In this case, you should separate each definition with comma. After definition, there comes a query that refers to previously defined CTE. Under the hood, CTE is unwrapped to the statement that queries underlying tables. Remember that result set returned by CTE is not persisted in database. Optimizer first unnests or inlines the CTE's logic, and therefore interacts with the underlying tables directly. That is the difference between CTE and temporary tables, which are stored in database. So, let's talk about the recursive form of CTE. Recursive form of CTE means that common table expression in its definition refers to itself. Let's take a look at example of recursive CTE. For this example, we will create a temporary table and fill it with some sample data. This table contains two fields, son name and father name. You see that John's father is Bob. Jack's father is Bob. Bob's father is Glenn. And so on. Also, you see that the same person can be a father and a son at the same time. So, let's say we want to get all John's ancestors. The following recursive CTE will help us to do it. Let's see what happens here, in the definition of the CTE. The recursive CTE definition must contain at least two query definitions: an anchor member and a recursive member. This part is anchor member. It is invoked only once. it returns 3 columns. The name of the person which ancestors we are looking for, his father name, and generation number. Now, let's take a look at recursive member. We see why it is called recursive. There is a self-reference here. Anchor and recursive members should be separated by union all operator. Recursive member is invoked as many times as it returns any rows. During its first invocation, this self-reference in from clause returns data from anchor member. Let's run anchor member and see it. And then, we are joining that returned data with our sons and fathers table. Look carefully at join predicate. We are joining John's father to the son column. And in select part we are retrieving father name. That means that we are getting father name of John's father. Generation number we increase by 1. Union all operator combines sets from anchor member and recursive member. So, of course, both members should have the same number of columns, with same data types. Then invocation of recursive member repeats. And during every next invocation, this self-reference in from clause contains result not from an anchor member, but from previous invocation of recursive member. That means that now, we are retrieving father name of the father of John's father, and so on. This repeats until our recursive member returns no data. In our case, Mike has null value in father name field, and because of our where condition, recursive member which is looking for Mike's father will return no data, and recursion stops. You should always be really careful with recursive member, its join predicates, and where clause. In next examples, we will see why. At the very end, we are retrieving all combined result sets from anchor member, and all invocations of recursive members of our CTE. And that's how recursive CTE works. So, from previous example you can see that one of common use cases for recursive CTE is retrieving information from some hierarchical data structures, such as son-father, employee-manager, etc. Now we will explore some other interesting and useful applying of recursive CTE. Let's pretend that we need a table filled with dates in some specific range. We can easily do this with recursive CTE. In the anchor member, we define the starting date of our range. In this case, it is January 1st of current year. We get this by using dateFromParts function. After union all operator, we define recursive member. You see that in every invocation of recursive member, date value is increased by 1 day, using dateAdd function. And please, take a detailed look at where clause. It causes the recursion to be stopped when we reach today's date. Again, correct where clause is crucial for recursive member of common table expression. Now, let's see what happens when we query our CTE. As you can see, we get an error. The message says that the maximum recursion 100 has been exhausted before statement completion. That means that according to server configuration, maximum number of recursive member invocation is 100, which is default value for SQL Server instance. To avoid this limitation, we have 2 options. First, we may change this setting on server level, but the most common way is to add a max recursion 0 hint to our query. Just like this. Now, let's run it again. With max recursion set to 0, the recursion will repeat until it stops, when recursive member no longer returns rows. That's why you should always pay special attention to recursive member. It's where clause, or join predicate, which limit returned result set. Otherwise, you will enter infinite loop, and it will run forever, until server has enough resources for it. If you are not sure if your CTE definition is final and correct, you may temporarily put max recursion value to some other level. For instance, 2 or 5, while debugging your query, and then switch it back to 0 again. Anyway, always be aware of it. The same principle is used in next example. Sometimes, we need to get a list of sequential numbers, in a range from some start value to end value. The following recursive CTE will do it for us. For more flexibility, start and end values and a step value were parameterized and put into variables. So now, we should get numbers from 1 to 1 million. And we got it. Now, let's get even numbers from 100 to 1000. We need to change start value to 100. End value to 1000. And step value to 2. Let's run the code and see what happens. And we got the list of even numbers from 100 to 1000. Simple as that. Another interesting and similar usage of recursive CTE may be getting the list of random numbers. Let's take a look at following code. It's more complicated, but the principle is the same. This CTE returns a list of 1000 random numbers, and these numbers' values are all between 1 and 5. Of course, all of these parameters may be changed as we need. We use here additional order column, which helps to stop recursion once we reach needed limit of numbers. I will not dive into details of how we use different functions, like abs, checksum, and new ID, to get random number. But it's not so difficult, and you can figure it out by yourself. Let's run it, and see the result. You see 1000 random numbers. And if we slightly change our select statement, we will see that all numbers are distributed pretty equally, so the list is randomized pretty good. Recursive CTE may also have multiple anchor and recursive members. We will see it in the last example of CTE usage in this lesson. Let's create a temporary table, which will serve as a source for our common table expression. It's a database interpretation of a simple decision tree. Every node has two edges, or directions, from it. Yes root, and no root. Graphically, we can display it like this. You can pause it here, and take a careful look. Our task is to find all nodes, which follow the node named Am I Hungry? For all roots, till the end of the tree. Let's create a recursive CTE for it. So, how it works. We have here two anchor members, combined with union operator. First anchor member returns the node name for yes root, and the second, for no root, for Am I Hungry node of our tree. Then, there are two recursive members. First of them takes all nodes, returned by anchor members, and returns yes root node for them. Second one returns no root nodes in the same manner. The where clause limits the result set. If yes root or no root value is null, then in next invocation, no rows will be returned. At last, in our select statement, we retrieve all nodes, which follow the Am I Hungry node. So, that's it for this lesson. Hope now you have better understanding of recursive CTE concept. At the end, I'd like to say that by the link in the description, you can find additional details about common table expressions, and particularly about their recursive form. Thanks for watching. Bye.